Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 106 and the question is 22, and from here on, by the way, all the questions are starred, so they're honours questions. So it reads, two roads cross at 45 degrees, and I've drawn those in black in front of you. A bus B is 602 kilometers from the junction. A car C is 9 kilometers from the junction on the other road. The bus and the car are moving towards the junction with speeds 402 and 7 kilometers an hour respectively, and are asked to find the velocity of the bus and the bus relative to the car, and the least distance between them. So of course the velocity of the bus, I'm going to resolve it without actually drawing. So this is going to be we'll say the velocity of the bus is going to be b cos 45 I minus b sine 45 j. And because of course they're both going in the fourth quadrant, it's going to be negative b, negative I. So you just plug that in, you're going to get this b is equal to 4 root 2. So you're just going to get negative 4 I hat, negative 4 j hat. That's going to be equal to the velocity of the bus. Next we want to get the velocity of the car. Now the car of course is just in the x-axis, or the I hat unit vector direction. It's going in the negative I direction, so it's going to be Vc is going to be negative 7 I hat plus 0j. That's correct. And then we're going to get the velocity of the bus relative to the car. Alright, so the velocity of the bus relative to the car. So VBC is equal to VB minus VC. Alright, so mathematically as normal it's very straightforward. However, crucially, C is in the frame of reference whereby it believes it is stationary. So VBC is equal to the velocity of the bus, which was negative 4I, negative 4j, minus negative 7I, plus 0j. Alright, and as a result of that, you're going to get that VBC is equal to 3I hat, negative 4j. Alright, there we go. Now, the next thing we're going to do is get the closest distance to them in their subsequent motion. And once again, I've done the theory of this very thoroughly in a video. I'll put a link onto this video if I remember. If not, just look at my playlist. So essentially, what we're going to do is we're going to get an equation of the line for VBC, and we're going to then work out how far the vector B is from it. So if I just get rid of my this part of the diagram up here. Alright, and just let me redraw it again. So we're told, initially in the question, we're told that B is 6 root 2 kilometers away from the junction. So here's B, and that's 6 root 2. Alright, and this is C. And we're told that C is a distance of 9 kilometers from it. But the vector we got was VBC. So as far as C is concerned, it is stationary. So next thing I'm going to do is draw the velocity vector VBC. So it's plus I negative j. So it's going plus I negative j. So it's going something like this. How do I draw it? Plus I negative j. So it's going somewhere. Wait, just let me see now. 6 root 2 and 9. So this is actually much further out. Actually, that's why we can make sense of it. So let's say this is much further out. Now, that's why it makes sense. So it's VBC. So C is stationary and B is moving. And this is B and this is C. And we know the vector VBC is going in the negative j but positive I hat direction. So it's going like this, like so. Alright? And we need to work out the distance of closest approach. So first of all, you should know at this stage that the distance of closest approach is when there is a 90-degree angle, like so. Alright? And this is going to be VBC. So what we're going to do is get the equation of VBC. We're going to plug in the point, this is going to be 9, 0, into the equation of the line and see how far it is away from VBC, as normal. Alright, so the first thing we need to do is realize what do we need to get in order to work out the equation of the line. So for the equation of the line, you need two things. You need a slope and you need one point. Alright, so we know that VBC is equal to 3I hat, negative 4j hat. So just to get the slope of that, it's just the tan, so it's going to be negative 4 over 3. So m is equal to negative 4 over 3. Alright, so we have the slope. Have we a point? And the answer is we do, because this is the motion of B and we're given the initial position of B, because the initial position is 602 kilometers from the 602 kilometers from the origin. Okay, but we're told we're told basically this is a 45-degree angle. So we need to resolve the displacement vector. Alright, so this is going to be very straightforward. It's just going to be 6 root 2, yeah, so it's going to be RB is going to be equal to 6 root 2 times the cosine of 45, and it's going to be 6 root 2 times the sine of 45. Now the directions this time are both positive because it's away from the x or the origin by in the plus plus quadrant. So that's just going to be 6i hat plus 6j hat, because the cos and sine of 45 are 1 over root 2. Alright, so we now know where B is. We know a point. It's 6i plus 6j. Alright, and we know the slope, because the slope was equal to negative 4 over 3. So the formula for slope m was equal to y2 minus y1 over x2 minus x1. So if we rearrange that, we'll find that y2 minus y1 is equal to m times x2 minus x1. And this, okay, so just plug in what we know. We know the slope here was equal to negative 4 over 3. And we want to plug in the point where B is. In this case it's plus 6i plus 6j. So this is going to be a 6. And so is this here. Alright, and just before I rearrange all that, I'm going to get rid of the piece of information we don't need anymore. Alright, so just have this. So this just becomes 3y minus 18 is equal to negative 4x plus 24. So 3y plus 24, no, plus, 4x, alright, and we're going to get negative 42, alright, is equal to 0. Alright, and that is the equation of the line of VBC. And what that means is that we now have the equation of this line. And if we plug in any point on this line, we will get 0, which is correct, which means we're on the line. And if we are not on the line, if we plug a point which is not on this line, we will get a positive number, or we'll say if we get the magnitude of it, we will get a positive number. And what we'll do is we'll divide this by the magnitude of the slope vector. So you knew that m was equal to negative 4 over 3. Like so the magnitude of that vector would have been 16 plus 9 square rooted, which is equal to 5. Alright, so we need to divide this by 5. Oh, you couldn't see that there. Let's get rid of the piece of information we don't need anymore. So if we plug in a point, the point C, which was at, as you can see it there, it's at negative or positive 9, 0. If we plug it in here, we get a positive number, and if we divide it by 5, we'll find how far that point is away from VBC. So the point was C is equal to 9, 0. So let's just plug that in. This is times 9. This is times 0. Alright, so it's 36 minus 42. So we're going to get a magnitude of 8 over 5. Alright, so let's just plug that into the calculator. And we get 1.6. Now the answer is supposed to be 1.2. If I can remember correctly. Just 1 second there now. Oh, that's why my algebra is so bad. There you go. Alright, 6 over 5, and that's 1.2. I try not to do arithmetic in my head, especially when I'm doing a video and I can't think. So 1.2, which of course is correct, and that was reasonably straightforward. So thanks for watching. Please pass it on to your friends and subscribe to my channel.